Commissioners.
Morning.
Thank you for taking the time. I'm here to present about look at our drone operations, specifically for treatment applications, and I'm going to highlight a specific field trial we did this past summer with a product called Vectobac FG+. So to kind of begin with some background, drones have several roles in our integrated mosquito management program. The first of which are inspections. So these are essentially taking a drone with a camera and surveying a uninhabited area where mosquitoes are produced. These could be mangroves, these could be freshwater swamps, but essentially it allows us to quickly assess an area to see if there is mosquito activity present. The second is a more involved version of that, which is mapping. This is where we actually acquire what we call remote sensing information. This could be images, this could be things like LiDAR, which is using lasers, to acquire more detailed topographical information about the given habitat. So we'll go out and use these different payload configurations on the drone to get information to more precisely target mosquitoes where they are. And then the final role that drones have are actually for treatment purposes. So we do granular larviciding with our drones, and this essentially allows us to be way more surgical and precise with our applications. So why use drones at all? Like I said before, they facilitate very surgical, precise treatment applications, which not only save money in terms of the material we're putting out, but it also improves how effective we can be with that material, because we're very much like the fine scalpel, if you want to think of it like in a surgical context. Drones just have so much more precision due to the GPS guidance systems they have and the mapping and surveying we do to support those operations. They're also much more efficient compared to traditional tools and safer. So whereas in the past, a field technician might go out with a backpack or on foot and have to dodge snakes and alligators, drones allow us to not only safely do that job, but also much more efficiently, because we can bypass all of that harsh terrain. And finally, they're much easier to use compared to manned aircraft. So instead of having to train and hire a pilot, which is much more risky as well, a drone is much easier to get somebody trained and safely operate. So, this plot here just kind of shows the growth of our drone treatments. So on the x-axis, we have the fiscal year, and then the y-axis, that is the size of the bar, the height of the bar, is the acres that we've treated with the drone. You can see in 2025, that dark blue bar, we've dramatically augmented our drone operations when it comes to larviciding. And this is in part due to having a dedicated drone pilot now, whose sole responsibility is to find areas that are drone suitable to treat. And we've also upgraded our drone platforms to more capable, larger drones, so we can just reach areas that otherwise before would be too big for us. Geographically as well, we've expanded our coverage. This series of maps shows Collier County roughly and our district, and you can see the red points illustrate where we've done drone treatments. In the past, so like in 2021, we focused much more in the eastern parts of the county, so Ave Maria, Immokalee, but with our new drone platform and our dedicated drone pilot, we've done a much better job this year, you can see in 2025, of expanding the areas that we're servicing essentially, especially along the coast, especially down in like the Henderson Creek area. We're just much more proactive now with our drone operations than in the past. So this area illustrates a typical habitat that we target with our drone. We have very nice communities all throughout Collier County popping up, but you have these fragmented habitats that remain, these flooded fields that produce millions of mosquitoes. So with the drone, we're able to effectively target them because these areas are somewhat too small for the helicopter, but also too big for ground-based equipment. So the drone that we use at the district is a Central UAS Technologies Precision Vision 40X. It is a rotorcraft capable of carrying up to 40 pounds of material, and it is a gravity-fed casting arm design, so it throws the granular larvicide material quite far. So in 2025, we did a field trial with a product called Vectobac FG+. It is a granular larvicide. It is rated for aero applications. It's a fine granular. What made us interested in this product is that it is an organic product. That is, it is OMRI listed, so it can be used in areas that are certified for organic food processing. And It is similar to other products that we use currently that we were curious to see how it would be effective against our mosquitoes here in Collier County. So the species that we're targeting is a very prolific one throughout most of Florida. It is the Culex nigripalpus species, the Florida SOE mosquito. It is the most abundant species that we capture in our district's traps, our CDC traps specifically. Its populations tend to peak in the summer. This plot here shows the mean Culex nigripalpus per trap for the past 6 years. So you can see in June, July, and August, you see a huge peak with the rainy season and the hot and humid conditions that follow. It is medically significant as well. It vectors for West Nile virus, St. Louis encephalitis, and Eastern equine encephalitis. So it's a very relevant mosquito in terms of public health for us to manage. And it also is capable of flying many miles from where it emerges, so it has high dispersal capability. So this species, even though it is produced in areas like this, it not only affects the houses nearby, but potentially communities miles away. So it's very important that we manage this species. So we had 3 research questions going into this field trial. The first is, can our drone, that is the TV40X, deliver Vectobac FG Plus at moderate application rates at uniform swath depositions? Second is, does the applied material reduce the Culex nigripalpus larvae within a flooded habitat like the image I showed earlier? And finally, what amount of residual control do we achieve? So not only does it reduce them acutely, but how long does that treatment actually last? What's our bang for our buck? So we designed a simple study to address these questions. The first is what we call swath characterization. So this is essentially putting the product in the drone and finding out what happens when it's applied over a given area. We have several experiments we do to find that out. The second is finding a study site and a control site to actually compare the treatment to a non-treated control site. We did the actual field application and then post-application sampling. So we did very thorough sampling for mosquito larvae within the sites respectively. And then we did statistical analysis to look at the results to see how effective our treatment was. So for swath characterization, we did what is considered industry standard. We set up a bunch of tubs in a collection line about 96 feet, and we fly the drone perpendicular to the collection line against the wind, and we collect the material that's deposited in each bin into baggies. So this is what that looks like. We set up tubs, and then we fly the drone at the center line of those tubs, and the material is applied, it's collected in the tubs, so we can actually weigh and figure out how much material we're getting, because that tells us if we're hitting our target application rate and what our drone settings need to be to achieve it. So once we perform this for several replicates, we weigh and count the results from each bin, and then we convert the amounts into pounds per acre per bin position to figure out, again, how close we are to our target application rate. So this plot shows the results without getting too in depth. Essentially, this is our footprint. So this tells us essentially, theoretically, what's happening when we take the drone with this product at the settings we fly, what's happening in our targeted areas in the field. So we developed a program in technical development to essentially take this data and analyze it in a standardized form to figure out what our ideal settings need to be to optimize our treatment. So it's essentially a really long computer program that we wrote to take this data and tell us what our effective swath needs to be. So that effective swath is just telling us what our how far each flight line needs to be from the next one to get as close as possible to our application rate. So with that, we can also simulate it. So this plot shows the simulation of what that overlap would look like at 50 foot, which we found to be the most optimal. So the proportion of the color of each bar shows what contribution of each flight path contributes to the total pounds per acre. So as fancy as it sounds, essentially just optimizing what our field settings need to be as accurate and by the label as possible. So here's the final plot, and essentially what we end up with is a 50-foot swath gets us an 8.57 pound per acre application rate at a coefficient of variation of 18%. So that coefficient of variation is just telling us how uniform our application is. Lower is better. it's one thing to have an application rate that averages to what you want, but the CV tells us that we're actually treating our areas relatively uniformly, which is what you want. Because sometimes you have mosquito habitats that are spotty, so it could be wet in one area and dry in another. You want to make sure that when you're applying a product that you're treating everything as close as possible to your application rate. So what we find is that we're actually treating with the drone in this product things relatively the same, which is good. So to get to our first question again, which is can we deliver the product at our application rate? We found that yes, based on our program and our simulation, we found that 50-foot swath operationally yields an 8.57 pound per acre application rate at a CV of 18%. So we're on target to treat what we need at our settings. For the actual field component, we had 2 study sites. The red box is our control site, and the green box was our treatment site. These were detention ponds that were prolific for Culex nigripalpus mosquitoes, and they were near a school and other communities, as you can see on the map as well. We set up what we call our repeated dipping stations, or RDS stations. So within each of the sites, we set up these observation points where we would go for 15 days post-application and sample every day to get that robust data to figure out what's happening day by day. So here's what those look like within the treatment and control sites respectively. We have our points, our monitoring stations, and our protocol was to essentially mark each one with a flag, and then we observed them for 15 days post-application. We performed 5 larval dips at each station, and we recorded our early, late, and pupae larvae. So our results, to break it down, let me just kind of fast forward. We essentially achieved a 99% reduction 24 hours post-treatment, which is very good. Essentially what this is telling us is that compared to our pre-treatment numbers of mosquitoes following the application, we essentially eliminated all those mosquitoes within 24 hours. And not only did we eliminate them, the square line here shows our treatment site. We maintained that reduction for 15 days post-treatment, which is very exceptional and not what we expected. We also did statistical analysis. We used Henderson's equation, which essentially compares the field reduction in our treatment site compared to the untreated control site. So this plot illustrates the average percent reduction in those populations of early and late instar larvae. So essentially what we're seeing is the higher the bar, the better the result. You can see here that we essentially maintained a 92.8% field reduction in our late instar larvae for 15 days post-treatment. So that's very good. It means that not only are we getting that initial population, we're maintaining that reduction throughout a little over 2 weeks. So we also looked at non-targets, specifically odonata, that is damselflies and dragonflies. There were a lot of other aquatic invertebrates in there that we noticed but didn't track per se, but with dragonflies and damselflies we did track. We didn't find any statistical significance in the populations following the application. So essentially what we found is that following the treatment, we didn't notice any difference in their populations that would have been impacted by our use of the drone in the product. So to answer our last 2 questions, which is that can the product reduce Culex nigripalpus larvae, and what amount of residual control was achieved? Well, we got a 99% reduction 24 hours post-treatment, and we maintained a 92.8% reduction across 15 days of our observation period. So to kind of conclude, drones are an integral part of our program here at the district. We're continually trying to augment and expand them because there's just much more precise tools that are now available to us. We found that the product that is Vectobac FG Plus can be applied at moderate application rates from a drone that we use here at the district. We found that it was also very effective at reducing Culex nigripalpus, which is one of the most significant species that we deal with here in the district. And we maintained control for 15 days post-treatment at 92.8%. And to kind of conclude, one last thing is we are looking at additional field trials of this product and others for 2026 to continue that research. And just want to thank the entire technical development team, operations team, research team. It is a team effort. We're always looking to innovate and find better, more efficient ways to do the work we do and keep the community safe. And with that, happy to take questions.
I got one.
Yes.
Do you have thermal imaging on that you can pick up the larvae clusters?
So We don't have thermal imaging on the treatment drone, but one of
Yeah.
our drones is
The mapping
equipped
one?
with a thermal camera.
Oh,
We've
awesome.
talked about exploring that as a tool to actually identify.
To find,
Yeah.
okay. I'm on it.
Questions from the commissioners?
Yeah, one question I have for you. Great presentation. I wanted to ask you with a 40-pound load, that's about 8 acres, or no, 5 acres at 8 pounds per
Yes.
acre. Are there any plans to have a larger drone so you're not reloading?
Yes. So the market is continually coming out with new,
Better
bigger
ones.
drones, and it's certainly on our roadmap to look at a platform that goes even larger than the one we have. I will say that we have 2 of the 40-pound drones currently. So realistically, based on numbers we've ran, we feel like we can comfortably treat over 100 acres a week easily. And we're targeting very important, like we have kind of a criteria of areas that are most important. So that's like proximity to schools, proximity to parks, communities, that we kind of target first, and then we go down the list. Because with the drone, there's endless areas in we're such a large district that we'd be busy all year.
David?
Thank you, Mr. Chair. Okay,
I have a question.
No, only from.
so if you go all the way back to the beginning, I have about 20 questions.
Yes.
Go to the first one where you showed the multiple conservation areas.
This one?
Go. Actually down, right there. Okay, so can you treat that from one location, or do you have to move for every one of those?
Yeah, for something like this, we'd probably need multiple staging areas. We try to find a LZ that can reach multiple blocks. We find it difficult though, due to limitations we have with maintaining line of sight and for safety. We always err on the side of caution with our drones. And so for something like this, it'd probably take a couple of different LZs to treat all of these
I would think
areas.
at least 3 based on what I'm seeing there.
Yeah.
But okay, and then Mr. Mark, I know you don't have enough to do, but I would be very curious to see even a rough economic calculation. Whereas, okay, let's say we treated it with a helicopter. Okay, so it's so much flight time, and then how much spillage, right, or leakage. It doesn't do us any good to be spraying asphalt and those things. Plus, it's not good for the environment, right? But so how much you waste? So I'm saying how how much would it cost in fuel, time, resources, and then how much material would be used versus how much was actually, we needed 100 pounds, but 300 pounds were used in the process. Just I'd like to be able to show the taxpayers that, because this is definitely more laborious, right? You can send up one pilot with a helicopter and do thousands of acres, and you're talking about 100 acres a week. Now, I'm not against the 100 acres a week,
Yeah.
but showing that, okay, but this is actually a good deal for the taxpayer. I'd be curious to see that at some future date, not like next month or anything.
Okay, absolutely. From a financial standpoint, we can absolutely do that. Do you wanna add in, timing to that as well, in terms of?
Well, man hours, because I'm just
Yeah.
curious, it'd be my dream that we would send a pilot out with a truck and do this. But are there 15 people with that pilot? I mean,
Yeah.
okay,
Yeah,
I'd like
that's-
to see the calculation to see how it all works out. And even if it doesn't in favor of the taxpayer, if we're more surgical, there's still a case to be made for this is treating just the right area and no more. Okay, next. Okay, well, back up. Okay, so what you left out here was, so we got this thing up and running, 2017, 2016? And then the US government said, okay, Chinese drones can't, and so the whole thing collapsed on us, right? So that's already left that part out. So is that why part of why our 2021, why we have less larviciding, because we didn't actually have drones that met the government's criteria? Is that part of that?
Yeah, absolutely.
Okay.
Certainly in 2022, 23, we saw that decrease as a result of that. But it also is heavily impacted by the platforms we were using. For context, the last treatment drone we had, which was also our first, was only capable of carrying at most 15 pounds, and was much more labor intensive just in terms of loading and battery usage, compared to the drone we have now, which is almost 3 times as much. It does make a huge difference. And also having a dedicated drone pilot who is able to do those missions and focus on that, whereas before the duties were a little more hybridized. So you had other duties that they were doing that drone treatments weren't the emphasis. So absolutely, the legislation restricting our use of drones played a huge part in it. But I think the increase in 2025 kind of speaks for itself in terms of how much we focused on just augmenting that.
But I thought in 2019, 2020, we had a dedicated drone pilot, and we're getting his pilot's license and everything.
So the roles at the time were much, like I said, much more hybridized. So part of what I incorporated when I took over the department was specializing the roles to focus much more on things like drone pilot is now a dedicated role, whereas before the technical development department had technical development specialists that were much more spread between different duties that supported other departments, which is still the case now, but now our drone pilot is exclusively on drones.
Okay.
So again, to your point, absolutely. We did have people whose duties included using the drones and treating, but now that is the primary duty, and I don't think that was the case before.
Okay, I'm just trying to, I don't think you left things out, but I'm trying to, bigger picture. Okay, next. Next. Okay, so in this area you were talking about dispersion rate, and then you got into that a little bit. But is the velocity of the spinner, using technical terms here, is that variable or is that fixed?
It's variable, yes, and that's one of the parameters that we experiment with. The design the drone has, you want to essentially maximize that RPM because that maximizes the distance the distance that the product flies out at. So for the drone, we want to maximize that distance that the product flies out of because we're dealing with efficiency as our main bottleneck, right? The battery life, the flight time that's impacted by that. If we can get that product to go as far as possible, then we can be more efficient and get our treatments done much quicker. That's kind of the main thing with that.
So back to your experiment, but you're also leaving out then height and then of course velocity, because those three things are what controls the dispersion, both in width and amount per acre, right? So have you
Yes.
guys been doing your own parabolic calculations or field testing to
Yeah.
figure that out? Because is it always 50 feet? Is it, what happens at 25 feet? What happens if you increase the rotation rate? What happens if you decrease the rotation rate? On one hand, you don't want, pilot can only do so much at one time. You can't be changing four things and keeping going at a level pace, but how does that work?
Yeah, we try to keep our parameters that we treat with the same, as close as possible between areas. So we do, again, like I said, experiments, and that's what the characterization involves a lot of, is setting different altitudes, seeing the distance at which the product goes out at different speeds. But essentially what we end up doing is kind of picking a parameter that seems quick enough to apply the material we need in the time we need it. And then ultimately the empirical data we get kind of determines everything else from there. Whether we fly at 100 feet or 50 feet above the ground or this speed or that speed, what we measure from the bins is the hard data, and from there we can determine our operational settings. And we try to match our field settings that we actually end up treating with as close as possible to that experiment.
Can you fast forward to the experiment?
Yes.
By the way, I love the academic nature. No, not academic, that sounds bad. It's actually the A word's a bad word. The practical research being done, I really appreciate that. I remember, and this district has always done that. I remember Jeff, Dr. Stivers, doing crazy tests out in Golden Gate Estates and testing the droplet of application rate of diprom and other things. Okay, so is this actual material you're using?
Yes, this is raw material, and the parameters are set to be the actual treatment parameters we would use in the field.
Okay.
Of course, it's somewhat simplified because there's no canopy. We try to minimize wind drift, but we get as close as possible.
You're approximating.
Yeah, and we weigh and count the material, and we perform several replicates so that we have that kind of statistical significance of our results. And we repeat it, different products, different settings, and we essentially try to narrow down our best operational settings. And best in this context means most efficient and closest to our target application rate.
And forgive me, could you go back to that picture where we had the big wetland and the road next to it,
Yeah.
either forward or backward, I don't care. So our truck, is that, so that doesn't mean it looks like a drone thing, it looks more like something for our, I forget the vortex truck or whatever the thing is called, because it's so large, or are you saying you're just treating the
So
wet
it's
area?
deceptively flat, I would say, in this photo. What you can see in this photo is this is one side of the field. There's also another side that with no road access that similarly looks flooded like this. This is an example of kind of a spotty habitat where the drone actually is a great tool because with the truck, okay, you may say you can reach this side, but the other side completely inaccessible. Again, also The vortex, I've seen it get stuck. The drone, you can just fly right over it. I mean, for us, going and staging there would take us probably like 15 minutes to get going.
Okay. I wanna be in the ground.
If I could also add that trucks can only provide an effective swath of 300 feet, which is why aerial applications are better for a location like this.
Very cool. Okay, next, go back to the, almost done. I love this experimenting. And then we, of course, clean up the larvicide, right, that we're using in the parking lot here.
Yeah, yeah.
Yeah, so you guys actually wrote, so I was thinking of our airplanes, right? Don't we have a drift calculator there, so we know at this flight, at this wind speed, that this is the anticipated drift, so we can shift. And so it sounds like you guys wrote your own version of that for.
Well,
this
so
product,
it's similar in that we characterize the product as it's aerially applied, so we know what's theoretically happening. We don't account for drift with granular typically due to the weight of
you're
it.
low,
Yeah.
and you're probably not spraying in
Yeah.
windy conditions, right?
That's more on the operational side. We don't treat on days where it's particularly windy or conditions aren't favorable. What our program essentially does is generate what the most optimal setting should be to achieve our target application rate and be the most efficient we can.
So do you use then GIS to provide the flight rate, or is it all just done
So-
in the field?
It's done in the field. The program provides the settings we need to input into the drone in
For
the
the
field.
offsets, like 25-foot offsets or 50-foot?
For the
offsets?
swath. So yeah, the offsets in that sense. It's not an offset per se, it's the effective swath which incorporates the overlap.
Mhm.
The simulation kind of provides it. So that would be the tail end of one of the passes. This would be the primary flight path. So this is illustrating what happens in the center of our treatment area.
Oh, okay.
So you can see the
Didn't say that, so,
yeah, the proportion of each flight path's material that accumulates to achieve the target application rate and the uniformity that follows.
And then after this hearing, I'd like to talk with whoever did the animation. That was really cool. I would like to know how to do that.
That would be neat, so I can tell you
I'll
that.
talk to you about that.
Pro tip.
I'll talk to you in your
Yeah.
office. Okay, thanks. Next, please. I think I'm almost done. Next. I love having the control. This is great too. So you go back at it, you dip around 5. But
Yep.
I love this. I love this. Next. I think. Yeah, I think. Keep going. Okay, yeah, I think I'm done. Thank you so much.
Of course.
Any other from the,
Thank you for the presentation,
Thank you.
it's very interesting. I'm wondering if, as a result of your studies, did this meet your expectation? Was it better than you anticipated? And then where does it fall with industry standard?
Yeah, so to your first point, it definitely exceeded our expectations, specifically the residual control. We were not expecting 15 days at the efficacy we observed. I do want to say with that, we're looking to repeat it multiple times to see is that something that will hold across replicates or was just the most favorable conditions. As far as industry standard, I say this product does meet what is kind of we expect from similar products, if not exceed it, because the product itself is not marketed as a residual product, yet we observe residual activity, and that is likely due to something I didn't mention, but the potency of this product is double comparable products that are also on the market. So yeah, we were very pleased with the result, and we go into it not really expecting one result or another. We just want to evaluate and see how it does on our mosquitoes.
Yeah, thank you.
Adam, how many drones do we have?
We have 2 treatment drones,
Okay.
and we have 2 drones that are equipped for other payloads, mapping, surveying, things like that.
Right, okay, so 4 total, two for mapping, that was.
Sorry, 3 for mapping.
Three for mapping,
Yeah.
okay, those are the much smaller ones.
Yes,
okay.
2 are smaller inspection drones, and one is a heavier platform for more larger payloads like LiDAR or more sophisticated cameras.
So the ones that are used for treatment of any type, you're going to do these experiments as well?
Yes.
Okay, because this one only shows one experiment for one model of the drones, correct?
One.
One experiment for one of the drones.
Yes.
Okay.
Yes.
So there are plans, or that you've already completed the other experiments for the other drones that are used for treatment?
Yeah. So the 2 drones we have for treatment are the same make and model.
Okay,
However, we are experimenting with manufacturing our own customized payload like granular payload systems. So I mentioned the casting arm design where it kind of spins at an RPM and throws the material.
Right.
Due to the program we wrote, we noticed some interesting patterns that aren't ideal that result because of how the configuration is, and that's a manufacturer provided model. Our drone pilot also does a lot of 3D printing, so he's been working on a custom granular spreader that's a little more optimized to make that even more uniform. So we're doing experiments to improve on what the manufacturer provided and make our own design.
And these will be done periodically when you look at new chemicals. to
Yes,
use.
yeah. We love looking at new products and putting it in our drone because what it does in a helicopter is not always what happens in a drone.
Okay.
And,
And you mentioned the spread of the drone, 50 feet is about.
yes, for this product,
For
the
this
settings
product,
we did.
right.
For
So-
yeah,
Out of curiosity, and I know this is a little bit outside this particular subject, is what is a helicopter, one of the Bell's spread rate?
60.
How much?
60.
60? And this is 50.
so it's pretty close. And I will say with some of our products, we can get up to 70, 60 as well. It really depends on the product. You know, the larger the granular, typically, the wider we can get that effective swath. Something like this is a little smaller than, or it's mid-size, you could say, compared to where products stand. And we're pleased with that performance. 50 is, for us, it works well.
Some economic benefit there. Thank you. Great presentation.
Yeah.
Thank you, sir.
Thank you for your time.
Real good.
Just want to say that if the public has any questions, we'll be around after the meeting and we're happy to answer.
Yeah, absolutely.